So the minimum amount of force that would be required to keep the whole system stationary would be 250 Newton. If you got your answer, very good. Let's discuss. Now let's consider it one by one. If these two blocks are not moving relative to each other, then let's find the condition of the minimum amount of force. If this body is not moving with respect to this body, then mg is acting downward on block B and the friction force would be acting upward. So the friction force should be equal to mg. Now friction force is mu times normal reaction and that should be equal to mg. Mu for this surface is given as 0.3 and the normal reaction would be the same as the applied force. So let's suppose the force is F. That should be equal to mg, which is 50. So this comes out as F is equal to 500 upon 3, 166.7 Newton. Okay, now if A is not moving relative to this wall, then again the mu is 0.4. The normal reaction at this surface will again be the same as the applied force. We can see that from the FBD, the horizontal forces must balance. So the normal reaction again is equal to the applied force and this should be equal to mg 100. From here the F comes out as 250 Newton. Now if you apply a force below 500 by 3 Newton, then both of them will move relative to each other. B will move relative to A will move relative to the wall. If you apply a force more than this and less than this, then B and A are going to come down together, but A is going to slip on the wall. And if you're going to apply a force equal to or greater than this, then the whole system is going to remain stationary. So the answer would be the minimum amount of force required to keep the whole system stationary would be 250 Newton. Simple? Straightforward. Okay. Now from here what we're going to do is we're going to solve as many problems as we can, because that's the only way out to learn, to understand and to master this topic. The theory is over. We are not going to study any more theory. Now we're going to play with whatever we know. And before we move ahead, I'm going to tell you one small thing. Suppose a block is kept on a ground and a force F is pulling this block, then the contact forces, that means the forces from the surface, is one is normal reaction and the other is friction force. Then there's an angle, there's something called something defined as the angle of friction. The angle of friction is defined as the angle which the resultant of the contact force make with the normal reaction. These are the two vectors, normal reaction and friction. You remember the addition of vector, parallelogram law of method of parallelogram law of vector addition? Now the resultant of this friction force and normal reaction will be something like this. And this resultant, the angle which this resultant makes with the normal reaction, if that is theta, then that angle is called as the angle of friction. Now as you can see from this triangle, tan theta is equal to perpendicular, which will be proportional to F, upon base, which will be proportional to N. Now F is mu into N. So it turns out that theta is tan inverse mu. So the angle of friction is tan inverse the coefficient of friction. Okay, now there is not much significance of this, but still this thing is defined and you should know that how this is defined, and this is called as the angle of friction, which turns out to be tan inverse mu. Okay, now suppose if you are asked what is the resultant of the contact force which is acting on the block, the resultant of the contact force. Now this time suppose the force is acting horizontally. If suppose the force is acting horizontally, and now if suppose you have been asked what is the resultant contact force? Now remember, contact force is the force which the surface is applying. The force which is applied by a body which is in contact with the block. Now the contact force is the force offered by this surface, by this ground. The contact force is both normal reaction and friction, because both the forces are acting by the virtue of contact. If there is no contact between the block and the surface, there will be no normal reaction and there will be no friction either. So normal reaction and friction are contact forces. Now the resultant of the contact force would be the resultant of normal reaction and friction. And this is not a simple arithmetic. The algebra will be the vector. So this is not simply F plus N. You understand this by now. You have to do vector addition of F and N. And when you have two vectors perpendicular to each other, the resultant is F square plus N square in this case. You know that? Okay, now F would be equal to mu times N, and N will be equal to mg for the vertical equilibrium. So it turns out that the resultant force in this case will be mg into root over 1 plus mu square. Okay, now this was a simple case when the force is horizontal, so that you easily get normal reaction as mg by the balance of vertical forces. But in cases when the force will no more remain horizontal, we'll see later on.